So let's take a look at some examples out of 3.3. So they ask us, what are the intercepts? So recall that an intercept is where we intersect the x or the y-axis. So we intersect the x-axis here and here, and we intersect the y-axis here. So the x-intercepts are, if we describe that ordered pair, it's to the right 5, but it's not up or down any. If we describe this one, that's to the left 5, but it's not up or down any. This is something that's true of all x-intercepts. The y-coordinate is 0. If we're not up or down any, then we're on the x-axis, and if we're not up or down any, the y value is 0. Now for the y-intercepts, there's only one y-intercept. It's right here. To get there, we don't go over any, but we go down 6. So if we're going straight down, we're not over any, we're down 6. And it's true that any y-intercept has an x value of 0, because if it's on the y-axis, if it's on this y-axis, we're not left or right any, so the x value is 0, and then we'll have a y value. So we would just list these 3 ordered pairs as our answer. So let me, for an x-intercept, the y value is always 0. For a y-intercept, the x value is always 0. So if we're given an equation and it says to find the intercepts, we need to know that. For an x-intercept, that occurs when the y value is 0. For a y-intercept, that occurs when the x value is 0. So if we put a 0 in for y, we can find x. So if we replace y with 0, we get x minus 0 equals 6. So the x-intercept when y is 0 is 6. And then for the y-intercept, we would put a 0 in for x. So put a 0 in for x. So we get minus y equals 6. If we ever have minus a variable and we want the actual variable, we just take the opposite of both sides. So if x is 0, the y value is negative 6. So that's the y-intercept. So we can graph that. Let's get some graph paper. So if we plot 6, 0, that's going to be to the right 6, up and down 0. If we plot 0, negative 6, that's over none, down 6. So notice that's an x-intercept and a y-intercept. All of these equations are going to be of straight lines that we graph for now. So we would just, if we have 2 points, we could draw a line through it, and that'll be our graph. Now, since the instructions say graph the linear equation by finding and plotting the intercepts, if we come up with this equation but we don't use the intercepts, if we use different points instead, then while that might be the correct line, my math lab is not going to give us credit for it. So we need to make sure that we do plot those intercepts to graph that line. Same thing on this one. So to find the x-intercept, let the y value equal 0. Put a 0 in for y. So 3 times 0 is 0. So that leaves us minus x equals 6, or x is minus 6. So a minus 6x corresponds to a y of 0. If we put a 0 in for x, remember that gives us the y-intercept. So put a 0 where x goes. 0 plus 3y is 3y. And to get y by itself, divide both sides by 3. So we get that y is 2. When x is 0, the corresponding y is 2. So now let's plot those points. So those are our x and y intercepts. So we're going to plot -6, 0. So that's to the left 6, up and down none. That's the x-intercept. And then 0, 2. So that's over none, up 2. That's the y-intercept. It seems backwards that the x-intercept would have a y value of 0 and the y-intercept would have an x value of 0. But if you think about it, the x-intercept only has an x value. The y-intercept has a y value. The other part of the ordered pair is 0. All right, this one says graph this equation, and we could do this without isolating x, but if we only have one variable, it's best to isolate that variable. So let's add 8 to both sides and get that x is 8. So we think about making a table. We graphed some similar to this in the last section. This equation says that x has to be 8. Y can be any number. Y can be 0 as long as x is 8. Y can be 4 as long as x is 8. So if we're told this is a line and we're told to graph this, oops, didn't mean to put that on top of this one. We need another page there. Now we can put it in there. So we're going to plot, I'll get this in here in a minute. We're going to plot 8, 0. So 8, 0, that's over 8, up 0. And then we're going to plot 8, 4. So over 8, up 4. Draw a line through those 2 points because it says it's a linear equation, which means it's a line. And there's our graph. Notice that's a vertical line. It's going up and down. Anytime we have x equals a constant, x equals just a number, it's always going to be a vertical line. Because if all x values are the same, that means every point is over the same amount. Well, if every point goes over the same amount, those points will be in line with each other up and down vertically. The last problem is similar to that. It just has the just a y instead of just an x. If we add 3 to both sides, we get that y equals 3. So this time, this is going to give us a horizontal line instead of a vertical line. If we only have one variable, that means the other variable can be any number we want it to be, as long as this one is 3. Y is 3. X can be 7 as long as y is 3. So any number we want to pick for x, y has to be 3. So we can plot 0, 3. We can plot 7, 3, and draw a line through those. And that's a horizontal line. A horizontal line at y equals 3, because every point goes up the same amount. Well, if every point is up the same amount, that's a flat line, a horizontal line.